Okay, hello there. So we are going to answer the mock 2020 ordinary level geological geometry question. But before I do it, I just want to talk about one thing that this question is missing. Okay, you can see the question up here in the top left hand corner, and it says the image below shows a photograph of an open coal mine, which I haven't included on this, but it is on the question sheet. A portion of a similar mine area is represented on the accompanying map located on the back page of section A, which is this, and the map shows ground contours at 5 meter intervals, vertical intervals. So the question is, part A, on the map supplied, draw a vertical section or profile on the line AB. So we're basically taking this land, slicing it down there and trying to show it up here. Part B, indicate on your drawing the difference in altitude from the lowest point to the highest point. So we're going to be looking for a bracket there of where the lowest point is to the highest point and indicating that on the map or on the profile. Part C then is over here where we have D, E and F. It says points D, E and F are outcrop points on the stratum, on the surface of a stratum of ore, which could be gold, coal, peat, whatever it might be, any mineral. Draw the plan and elevation of the triangle DEF. Now then, with that triangle, part D, we're asked to determine the strike and dip of the stratum. I want to just highlight first here, this is missing from the question, which is a road. Now this can and most commonly will come up where you're given a section of a road and you need to find the width of the road, and then you either need to cut or fill the road. And in the instance of this first point here, you're given the width of the road, it's at 75 meters above sea level. Your cut ratio is 1:1. The contours are in 5s, so we would generally cut for every 5 meters we go up, we will move out 5 meters to cut away that land to make sure that the slope is applicable so that the land mass doesn't fall in on the cars. So from the edge of the road, I'll be stepping out there at 5mm intervals, and every meter I go out, I'm actually getting higher and higher up in the air, so they'll be matching off at each contour. That is my cut. And then this is our filled in on that. Again, this is just an example from the book. Just wanted to highlight it to show that the spaces for this are 7.5s. The reason being is because our ratio is 1:1.5. When we convert that to our 5 meter difference between contours, that changes to 5:7.5. So the height difference is our 5 meter intervals, but then out, when we come out to support that piece of land, to support the road, we're coming out at a ratio of 1.5, so therefore the gaps are 7.5. Again, they're going to be marked off accordingly with the contours, so as we get further and further out, we're actually getting lower and lower down. But anyway, they aren't on this question, but I just wanted to highlight them to make sure that people are aware that that is another area that can be asked, and for revision purposes, that's something that you need to look at. So we're looking here first off at the profile of the land, and to quickly explain that here, there's our land, it's being cut, this is our profile. So we need to create contour heights and then create the shape of the land. Okay, so starting off here, my contours are in 5mm or 5 meter distances, and our scale is 1:1000. So what I'm going to draw that is every 5mm we're going to have a contour, or a height line, should I say. So every 5mm, and I'm going to draw these lines in red. Try to get my head out of the way. Actually, what I can do is I can draw these all the way across the page, because I'm going to be using them for part C and D of the question anyway. So again, try and keep my head out of the way of the screen. Okay, so there's our height lines, and what we're looking at here is A to B is our section. We're going from 50 all the way up to 85 is our highest, so that is a difference of 35 millimeters. So if I start here, 50, 55, 60, 65, 70, 75, 80, 85, although looking at this is on 50, 60. So what I do is our lowest contour is on 40, our highest contour is on 85, so I'm going to go up at that gap rate: 40, 45, 50, 55, 60, 65, 70, 75, 80, 85 and 90. Okay, and it's important that you label these in order to get to grip the question and to understand it fully. So what I'm going to do is, wherever this cut meets a contour, I'm going to bring it up to its corresponding contour. So this is 50, bring it up as far as 50, put in a nice little heavy mark there. Next one, 55, show where you're getting the lines from. 60, bring it up, heavy mark. 65, bring it up, heavy mark. 60, bring it up, heavy mark. Just remember as well that this question is guaranteed to come up in your Leaving Cert exam, so it's something that we should definitely be comfortable with and able to answer fully. And for the revision purposes, I would definitely concentrate on questions, previous questions that have roads on them as well. So again, just bringing these all up to their corresponding height lines. This is 80. Now this contour here doesn't have a number, so I'm going to presume it's 75, 75. So when we bring that up there, we're going to go to 75. Again, 75 again. We're going to presume 70, and it goes back up to 80. Again, I'm following the contours along here, I can see through my set square. And then this next one then is 85 again. Even though it doesn't hit it, I'm going to put it in anyway. The reason I put that in is because it will give me a guide as to where the shape land is going. That's a maximum height there. I'm just going to tip off that, come back down, go a little bit below, and you're just getting a nice smooth curve here. Now these two are 75, so I'm going to go slightly below that and then back up. Okay, now we're going to indicate, okay, so that's part A done. Then part B is to indicate the highest point and the lowest point. So the lowest point here between A and B is our 50, and 85 is the highest point. So if I bring that across like so, bring that up there like that, indicate via an arrow and label. So indicate on your drawing the difference in altitude from the lowest point to the highest point. Takes all of 10 seconds to label it, but again, you're explaining to the examiner, you know exactly what you're being asked. So part C then is points D, E and F are outcrop points, and what we're going to just do is bring these up to their corresponding height location. So E is 50, so if I find 50, travel across here, there is E, again just join that up. F is 60, bring that up, find its location there, and D is 80. Bring it up, match off its location there, and join them up. The first thing, we're going to join them up in plan. D, E, F. How do I know D is joined to E? Because that is what was, that's the order that they were mentioned in the question. It's D, E, F, not D. Or doesn't really matter there. That's the way they're joined up in there. So this is D, F, and E. Now what we have here, I'm linking this to another area in the subject. This is just what we call a laminar plane. It's a section of a plane. It's a triangular section of a plane. This is our plan view, and this is our front elevation. Okay, now if we look at our, I'm just going to insert another picture here now for a second. If we look at our definition of what a strike is, okay, strike and dip. So the strike is the bearing of a level line on the surface of the stratum, is usually related to the compass north, and it is shown in plan. So compass north is going to do with plan view, and a level line, that's to do with our front elevation view. Now if you were to look at a picture on a wall and you were to say it was level, that's a horizontal reference that you're talking to. So the level line is going to be drawn in our front elevation, and I'm going to bring that information down to our plan, and that will give us our reference to compass north in plan. The dip then, we're going to use the strike to find the dip, and the dip is simply the angle a stratum or piece of material makes with the horizontal plane, which essentially means the slope of the stratum, which again essentially means the angle of inclination with a certain surface. Okay, so like my set square there, what angle is that making with my drawing board? So in our front elevation here, we're going to take our red pen again, and we're going to draw, actually it's already red, so I'm just going to draw in a different colour here. I'm going to draw, pick my middle height and draw this line called F1. With F1, I'm going to find F1 in plan here. So I bring 1 is on the line DE, so I'm going to bring that down to the line DE. There is location 1. What you do in one view, you must do in the other. So we have F1. And now what I'm going to do is I'm going to look, here's a little eyeball. I'm going to look in the direction of that arrow, or of that line, because it is a true length line, and I'm going to get the angle of inclination. So what we're going to do here is take sliding set squares and create an auxiliary view looking in at F1 as a point. So once I see F1 as a point, I will get the angle of inclination of the plane, or as it's called in terms of this question and in terms of materials and minerals, it is called the dip, but essentially it is the edge view of a plane. So take E, bring E up here, take one F1 and take D and bring them up this way. What we're looking for is we're looking for heights here. Okay, so basically instead of us looking at the front of this object, like the front door of your house, you're now moving around your house and looking in this direction. Okay, so what we're going to do is, where we're going to get those views, we go back 2 views, 1, 2, and we take them from up here. Now we already know those heights. That's 80, that's 50, and that's 60. However, for me, I have 40 as my 0, so that's a 10 difference. So for E, I'm going to come up 10. For F is on 60, that's a 20 difference. So I come up 20. And then D is on 80, which is a 40 difference. So I'll come up 40, and what you should notice by right is because this is an edge view of a plane, this line should be dead straight. So when I have this 40 millimeters in here, if I connect D to E, F should be on the exact same line. And what you know, when we draw that in, that is the edge view of my plane. Looking at the edge of a piece of paper, the edge view of any surface, I now have the edge view of my plane. Is that the answer fully drawn out? No, it's not, because I have to indicate that this is the dip. And once I have that done, I've now indicated and shown to the examiner I know exactly what I'm talking about. Okay, so